so we'll start with the session. Good afternoon, everyone, and a very warm welcome to the CII webinar on measuring what matters in modern manufacturing, ROHS, compliance, coating thickness, and elemental analysis. We are delighted to have esteemed industry professional, delegates, and speakers joining us today. Your participation is invaluable as we explore critical aspects of modern manufacturing standard and quality assurance. I'm pleased to introduce our distinguished speakers for today's session. It's Mr. Mahendra Nimkar, South Asia Commercial Leader, Hitachi High-Tech India Private Limited, Love Mishra, Customer Service Engineer, and without any further delay, I now hand over the session to our panelists to share their insights and expertise. Over to you, sir.
Thank you. First of all, I would like to thank CII for giving us this opportunity to share our experience. So I would like to make this webinar not as a just talk, but just to share our experiences, what we learn every day in the market. I have with my colleague, Mr. Love Mishra, who is our application specialist, and Neha Karni, she is our marketing manager based out of Singapore. So without further delay, I will start. I will share my screen.
Yes, sir.
Okay. I hope you can see my screen now.
Yes, sir.
Okay,
Just
so I'm putting into now PPT mode.
yes.
So first of all, I would like to thanks all the participants to join this webinar. And as I mentioned, this is basically would like to share our experience, what we learn from customers like you. And we also basically try to improve our offerings based on that. We try to share our knowledge, our experiences to different group of customers, and that is what basically Hitachi High-Tech is trying to do through this webinar. So, as Reshma mentioned, my name is Mahendra Nimkar. Basically, I am basically Hitachi High-Tech Analytical Science Group. So that is a division of Hitachi, where we deal with the equipments, meaning scientific instruments. So my colleague Raghunandana, he will join maybe later at this point of time. So we will today see the ROHS compliance, elemental analysis, and coating thickness part. So just to begin this to come to the context, I mean, this is we see what is the kind of mega trends globally happening. So the population is now growing, and by 2050 will be touching around 9.7. So you can imagine what kind of consumer goods will be required at that point of time. I think demand in mobility is growing. Electric vehicles are growing. So if you see, we are really living in a very diverse and VUCA kind of world, correct? So in last decades, we have seen that a lot of services converted into app, like for example, Ola, Airbnb. So we saw that earlier we used to go to railway station for making the reservations. Now we can do it on IRCT, see app or internet. So these kind of services are basically converted into the app-based model with the smartphones. Now the new trend is basically again where we are basically making the product smart. So it could be refrigerator, it could be TV, it could be any other devices, even a small thermos. I think they also have the temperature indicators nowadays. So this is the new era, I would say, and we are witnessing this change in our lifetime. So this is really fascinating to all of us to see these changes, what is happening. So, as I mentioned, from just to brief introduce our company, we call it in Hitachi we call it HAN, that is the Hitachi High-Tech Analysis Group. So we are it's a newly formed company. Earlier, It was a different groups. Now we in just recently we merged together. We deal with some of the technologies like XRF, optical emission spectrometer, LIPS, thermal analysis, spectroscopy, liquid chromatography, and so on. Globally, 900 people and seven manufacturing locations. So today we'll see basically what are the key drivers in the market, some of the new trends, what we see, the ROHS, what is happening with the ROHS in India as well as globally, some of the techniques for measuring the ROHS analysis and coating thickness with XRF. And then we can take some question and answers. So I like this slide very much. So from manufacturing to recycling, I think everybody is aiming towards reducing emissions, improving health, safety, sustainability, and these are the buzzwords. Okay, AI, Gen AI, lithium-ion batteries, fuel cells, smart devices, and so on. Mobility, for example, power and energy. I think our world is around basically these things only. And if you see, everybody is looking for safety, everybody is looking for sustainability, which we don't know what will happen for the resources on the earth. But I think I'm sure we see different opinions from different geographies. But as a manufacturer, as a company, as an organization, it's our responsibility to make our products safer for our generations to come. So coming back to like regulations and quality, I think if you see, you take any of the company you belong to, any of the segment industry you belong to, it could be infrastructure, mobility, pharmaceutical, healthcare, consumer electronics, or food feed, which basically Hitachi cater to all these companies. Regulations and quality is becoming the prime importance for any industry at this point of time. Everybody is looking for quality, and at the same time all the governments globally are increasing the regulations. It could be any kind of regulations. I'm sure you must be facing this kind of a lot of pressure from government agencies for quality control or waste management kind of things. So I think this is a no secret now. So this is one example which I want like to give always, what we are doing in EV. For example, we earlier we converted our IC engines to the energy vehicles. Okay, we converted to LIB, lithium batteries. We put batteries in that. So again, the criticality of the product has going up. It becomes more complex. Now we are talking the autonomous vehicle. So there are a lot of chips into the car. The cars are becoming very smart, and I'm sure there is in future, maybe after 10 years, 20 years, 50 years, you will see all these flying cars. Okay, so what is happening is that the hardware requirements, the software requirements are increasing always in the car industry. So if somebody is looking for automotive industry, you will see probably after few years the requirements or the quality of the product which we require today in automobile industry will be equivalent to the aviation industry. Okay, we don't know. I mean, this is just the future, and I don't think so. It's far away. It's coming. It's coming. Now, if you see the Tata Motors, nobody would have thought 25 years before that Tata Motors will also make iPhone for Apple, and maybe 5 years before nobody would have thought that Tata will become a semiconductor company. So I'm not sure whether we need AI lot or not, but one thing is very sure: the automotive companies and today's electronics companies will become tomorrow's semiconductor kind of companies. Okay, so this change we are definitely seeing, and we are witnessing, and we are catering to this market. So this is what is driving currently at this point of time. You take any industry, it could be foundry, fabricators, as I mentioned, automotive, it could be battery, any industry today, safety, compliance, performance of the products or parts, reliability, yield, I mean the failure rates, and at the same time the cost is very important for any of these companies. And what it means basically, it's driving is basically implementing new R&Ds. We are basically finding new materials. There is a lot of R&Ds happening. There is a raw material testing happening. So for any company, for us instrumentation company, basically testing is going up. Zero tolerance policy. Earlier we used to check like a sampling. We used to do sampling, but now it's 100% checking is required. Calibrations and traceability. So a lot of audits, documentation is required. Your customers are not believing on Excel sheet. They want something report generated out of the system or instrument. And of course, the service is also required. Uptime is very much important nowadays. And customers are also not believing the reports on one technique. They want complementary techniques reports, okay, just to justify the results. So this is probably I would say the driving a lot of instrumentation and testing scenario, or I would say the quality control scenario. And when it comes to compliance, we also we also not expert in everything. So we also collaborate with different customers, with commercial testing labs. We learn from them. For example, today we are going to talk on ROHs. We also deal with Euro 6. Some of our products goes into the Euro 6 market for oil and gas industry, for example. We deal with ARB regulation when it comes to X-ray based products. We have to deal with ARB norms. You as a customer also must be looking some different norms. So we also try to collaborate, understand, and make the production offering accordingly. So let us go back to our main topic. So today, if you see in Hitachi, we always say trust but verify. So trust your vendors, but verify what they're basically providing to you. So I'm just giving one example here. If you look at the semiconductor industry, the product design is happening at different place. The fab or basically manufacturing at a different place, packaging at different, the component is making putting into some different place, and final assembly or user could be at different place. So there is a very complex supply chain. So we also always recommend to our suppliers or and our customers also, trust your suppliers but see and verify at your end also, and of course push them to again check to their end also. So whether the achieve the specifications are agreed or not, whether they are maintaining this compliance certificates or not, because finally the obligation, the penalties are with the companies those are making the finished products. So these are the some of the technologies I'm going to talk today for ROHS and coatings. So when it comes to ROHS, I think it is started somewhere in 2005 in Europe. That was the first directive. It came into the picture, and then it spread globally in a different country to China, USA, and other parts of the world like Japan, Korea. India also has ROHS, so it comes with we call it WEEE, but it is a similar regulations are there. Even Bangladesh also has ROHS now. So now whoever is importing the material, earlier it was to be like only checking the ROHS if you are importing something to Europe or some other developed countries. But now the situation is changed. Even for consumption in India, the product has to be ROHS compliant. So I think I'm sure people know what is the ROHS. So ROHS is a restriction on hazardous substances. Primarily, it was given by ROHS. So there is a directives number 2002-96 EC, and there are some different directives has come. But basically, it talks about the elements which are banned. So nomenclature, some people say ROHS 1, some people say ROHS 2. But the first part is basically six elements, that is the cadmium, lead, mercury, hexavalent chromium, and bromine. Some are the bromine flame retardant substances are there. So these are the limits are given for cadmium. It is 100 ppm. Rest of it is 1000 ppm. Now recently in July 2019, Europe has also banned, or they come up with a new ROHS regulation for four phthalates mainly, and that is also banned now. So these phthalates are typically used in plastic substances for a softening of the plastics, typically in a plasticizer. So these are also banned. So most of the products which goes into plastics, these has to be ROHS compliant. That means you have to check the phthalates also. But if you look at the India approach at this point of time, so we come up with the ROHS regulation, or we call it the e-waste regulation, that somewhere in 2022. And the rule came into force from 1st April 23, but government also extended it for 2 years, and now the new date was 1st April 2025, which is already passed now. So as per the Indian ROHS rule, the first six substances, as I mentioned, cadmium, bromine, lead, mercury, and chrome, are definitely banned. And of course, phthalates also mentioned, but there is not much of the penalties on this. But first six substance has to be tested, and four phthalates are also definitely tested. But I'm sure for testing phthalate, it requires a lot of, I would say, instrumentation and some expensive things. So I think government is not pushing much onto this part. But any company, for example, a lot of bigger companies, the bigger brands are already doing this testing in house, or they are sending samples to outside. So now the government also has come up with the responsibility. So at the left side, I have mentioned basically which are the uh, products are coming into that. It could be all the information and technology equipments, commercial, consumer electrical and electronics goods, photovoltaic panels, large, small electrical electronics equipments, like home appliances, for example, toys, leisure, sports equipment, medical devices, laboratory equipments, and the components. So everything now basically falls into this, has to be ROHS compliant. And now with new regulation, government has given responsibility, which is like a legal kind of binding, to manufacturers, to producers, refurbishers, or dismantler and recyclers also. So these substances should not be there in recycling also when you recycle it. Now we see a lot of recycled plastic is coming, for example. So we have, who is making the recycled plastic, for example, they also need to be careful on this particular part. So some of the tools we'll see. So EDXRF, when you talk about EDXRF, is one of the great tool to check the ROHS. So we call it the screening test actually. So there are a couple of technologies in that. So if you do not have EDXRF for screening, then definitely you need to send a sample outside to the commercial testing lab, or you need to have all ICP or GCMS or UV visual spectrophotometer in the lab. So generally, what most of the manufacturing companies, what they're doing, they're going for EDXRF, and they are doing screening basically. So as per the ROHS guideline, the sample has to be homogeneous. So when I say homogeneous, the parts which you can dismantle or disintegrate, okay, like for example, fastener, nut and bolt separately, or knob separately in the machine, for example. So every part has to be tested separately, and every part has to be ROHS compliant. So it becomes like a too many parts, for example, and too many batches, too many vendors. It's not possible to send everything to outside testing lab or do it in-house. So people are basically following EDXRF as a screening technique, which is a very quick and good. So once, for example, we can also have some kind of uh, window, I would say. So for example, if you do screening for, I given the example here, when you do for a screening for EDXRF, then let's say cadmium limit is 100 ppm. So if you see the result when you do the screening or testing with the EDXRF, if it is a more than 130 ppm, it is definitely failing. If it is a less than 70, it is definitely pass. So you can create this kind of range, okay, this kind of window while programming it. and it will show you pass and fail for all the products. If you are still it is filling in between the gray area, then you can basically send it to the outside testing commercial testing lab, or use some different technology. So this is the way generally in most of the electronics companies globally and in India also follow the similar way for ROHS compliance. So what are the benefits for XRF? I think it's very easy, very fast. You can get the results in 30 seconds or maybe max 1 minute kind of time. Very easy to use. There is no sample preparation. Absolutely, a layman can use the instrument. It's a non-destructive, so you can keep the sample as it is. Very cost effective, and then of course it is, for example, proven with the technique. It has ASTM and IC guidelines which supports, for example, in terms of certification or in terms of guidelines, if somebody asks you about which method you have used. So it's a very versatile. You can do solid sample, liquid sample, paste, powder, everything you can do test with the XRF, EDXRF instrument. So it basically reduces your analytical cost, because if you want to test it and give it to the outside commercial testing lab, it's not only time, but it costs you also, and then probably it may take 7 days, or maybe we don't know how much time it will take to come back with the results. So that also you can in-house, you can test it at least within a range. You can say it is a pass or fail, and you identify very quickly. You can take the result and take the decisions very quickly there and there itself, and you can reject material if it is not passing. So generally, there are two different techniques in XRF solution. One is a handled XRF, which is also good, which is a great tool for bigger parts. So and our own company is also using the handled XRF for bigger parts, like for example AC panels or big panels, for example. Uh, for smaller parts, we always recommend to go with a benchtop XRF because it's more accurate. But depending on the need, you can choose the basically which product fits. So handled XRF comes with a benchtop stand also. So even if you have some smaller samples, you can do on handled XRF also. But generally, if the samples are small and if you need really very accurate analysis, we recommend to go with a benchtop XRF. Also, benchtop XRF can do elemental analysis. So not only ROHs, you can do some other elemental analysis also. So XRF is also basically a great tool for elemental analysis. So XRF basically comes with metal calibration, plastic calibration, and solder calibration. So these are the typical things in industry want to check for ROHS compliance. In handled XRF generally is suitable for pure solder metal, but if it is on the PCB, then it's very difficult to keep it in on the hand and check it on PCB. So these kind of things you can do it only on benchtop XRF. So bulk XRF, or we call it the benchtop XRF, is very good, uh, though it is slightly costly, but it is a very good accuracy. Repeatability is very good, and at the same time you can do very small samples also, small fasteners. If you want to do, let's say, ink or something like that, you can do it. I'm sure you know that even the ink which you are printed on your product, that has to be ROHS compliant. And of course, at the same time, you can also do some coating analysis also, which are if you're coating some kind of uh, plating, for example, on our samples. So coating thickness measurement is also possible on benchtop XRF. So of course, there are multiple advantages as I mentioned. So it's a very versatile. It comes with auto sampler generally, so you can have multiple samples you can keep. So in one go, you can do the 12 samples one by one, of course, and you can do some coatings thickness. Typically, in electronics industry, is gold over nickel or copper, which is the kind of typical applications. You can do it. Again, it is connected with a computer, so you can store all the data. You have a camera, you can see on which spot exactly you are measuring the ROHs. It comes with the three different collimeters, one 1 mm, 3 mm, 5 mm. So you can definitely locate a proper point and measure basically the particular part on even the big PCB. If you want to measure one particular area for compliant one particular, let's say, component, you can do that with the benchtop XRF. Because of this, it comes with a stage. So generally, if you see, for benchtop XRF also, or even for handled XRF, the limit of detection is very very small, very less. For example, in a plastic, for example, if you see here in P or PVC, if you see, if I look at cadmium, the LOD is 1.3 ppm, but the requirement is 100 ppm. So the benchtop XRF or even handled XRF basically can do the job very well, because the LODs are very very less actually. So, and even if it's 3 sigma, I think you can confidently say that whether your result, I mean your sample is pass or fail. So that's a very good advantages for EDXRF for ROHS applications. Similarly, for metals, again, as I mentioned, for aluminum alloys or brass, LODs are very less compared to the asking value. I mean, if you look at the lead, mercury, the asking value is 1000 ppm, but here the LODs for lead is like 5 and 6 kind of thing. So it is very good kind of analytical tool based on LODs for checking the ROHS compliance. So it is not only about the ROHS, but there are many other compliances also. When you talk about the reach or twice testing, for example, there are so many banned materials are there which you cannot test with XRF. When we see the elemental analysis from magnesium to uranium, typically you can do check with the XRF in air. But at the same time, if you uh, want to measure the sodium, then in that case probably you need to have vacuum attachment, because because of the sodium, the characteristic or the sodium itself, then only you need uh, vacuum options, for example, or you uh, otherwise most of the, like from magnesium, even light elements, you can check in air with the EDXRF instrument. Of course, the accuracy may not be that great compared to the destructive method, but I think it's better. So there are some examples here. So we are checking one example resin here. We have taken some photo. It's a small resin, and we are testing it. For example, lead with XRF. It shows 538 ppm, and ICP it is showing 524. So very close. It's not that it is very off actually. So at least you can say it is passing, because the requirement is 1000 ppm for ROHS pass or fail. Now there is one good example here is basically if we have like a jacket, I mean some knob with jacket, for example. So lead content with the cord inside, it shows 196 ppm. But once you measure only jacket, if you remove the cord inside and only measure the jacket, it shows 240 ppm with XRF, and with ICP it is showing 249. So again very close. So the idea here is basically telling you that with EDXRF, with the benchtop, typically you get very accurate results, very close to ICP. Of course, ICP results are very accurate, but it is a destructive technique. You need to dissolve the sample and so many other things you have to do. With EDXRF, you can do the similar kind of analysis without any sample preparation and no destruction of the sample itself. Something same with we have taken one metal sample here, for example, and we want to check it here for lead and cadmium. If it is a plated sample, now if you plated sample, you will get the results are very different. For example, in cadmium here, uh, the XRF value showing 76 ppm, but if you remove the plating on top of that, it is 113 ppm. So now it is filling. Okay. and ICP value also suggesting it is failing. So you need to also remember that if you're checking any sample, it has to be, you need to remove the plating also on top of it. Then only you have to remove, you have to check the sample. So it's a very simple operation. I think, as I mentioned, you can put multiple samples. If it is a small powder liquid, we provide cups. You can put the sample there with the auto sampler, for example, and you can get the results very quickly. You can print the reports, create your own company template, and send reports to your customers, for example. Okay, so we'll go to the next part, ROHS 2.0, or let's say 3.0, which we're talking about phthalates mainly. So typically, if you look at the EDXRF is taking part of the first ROHS 1 or 2, for example, which is the elemental part of it. We talk about the screening mainly. And if you want to do precise analysis, again, you have to send it to the outsource it, or need to have GCMS or UB or ICP in the lab. Now, when it comes to phthalate, typically these are all organic substance when I say phthalate. So definitely you need to, earlier everybody used to send samples to the lab for doing on GCMS, but Hitachi come up with a new technique, that is TDMS. So our target was basically to do the phthalate analysis within 10 minutes, because the GCMS take maybe 60 minutes, solvent GCMS. But then if you want to send it outside, it may take 7 days also. Okay, it depends on the lab and location of the lab also, and how much load they have. So our goal was to do the screening of phthalates in the lab, in the manufacturing facility within 10 minutes, for example. And Hitachi has come out with the patented technique. Sorry, patented technique called TDMS, thermal desorption mass spectrometry, where basically in conventional GCMS, you know that basically we are vaporizing the sample, and then we have column, and then it goes to MS in GCMS typically. What we have done is basically we removed the column part. We are just vaporizing the sample and directly send it to the MS. So this is much complicated, but just in a simple way, I can tell you that we removed the GC part in between, or gas chromatography part in between, and the sample is directly sending to the MS with ionizing with the EPCI. So that is very simple way of doing it. Uh, and it doesn't require much of sample preparation. You have to just cut the sample. Let's say if you have plastic sample, cut the sample, weigh it, and keep it in the HM1000 auto sampler. Okay, so automatically it's get heated up, it's get vaporized, and then goes to the MS. The software, or basically it is, the system is tuned to recognize or to measure these four phthalates. So automatically you get the results on the screen. So that's what quite easy, I would say, and just at this point of time, I would say. But it comes with the auto sampler, so you can do 50 samples at a time. It is a very high throughput system, low running cost, because we are not using any helium gas, we are not using any columns as such, no solvents, so you don't need a wet lab also for doing that. So very inexpensive kind of instrument it is, very low running cost, I would say. So we have done some comparison. If you go with the HA1000, which is TDMS, Hitachi's TDMS, let's say running cost is around $10,000 per year. If you're doing like many samples, like let's say for example 10,000 samples. But if you're doing with GCMS, you may take roughly $50,000 plus. You need one person to operate the GCMS. Here, a normal lab guy can operate HA1000 also, and the sample analysis time is only 10 minutes. So this is very much advantageous for the electronics company or home appliance company, I would say. Okay, in their quality control department, you can have this system. We already have some installations in India and globally also for this instrument. Very interesting model. So very user friendly actually. Just keep the sample, weight, and put it into the pan, and keep the pan inside the machine. At the same time, you can do put 50 samples, and one by one it will do the analysis, and you get the results, and there is no helium required. Okay, so this is the first part about the ROHs. I'm just trying to cover the basic things. If you have any questions, you just put into the chat. I will try to answer this some of the questions later after finishing this second part. So coating thickness, I think all of you know. We talked about XRF, but just in coating thickness, we the first part when we talk about ROHs, it is typically the elemental analysis. Okay, in though it's we talked about ROHs, but it is the elemental analysis only. We are basically checking the elements. Now in coating thickness, we are checking the thickness. So basically, what we are doing here is typically what happens in XRF. Your incident X-ray or primary X-ray falls on the sample. It basically ejects out some of the electrons, and the secondary outside shell electron tries to take the place, giving out of some the characteristic X-ray we call the fluorescence. So now this we get this kind of graph, intensity versus keV or electron volt. The electron volt is basically the energy required to push the electron out of the shell, and whatever the counts you get is basically the intensity for this the element which is present. So we are using the same thing in converting this calibration into the thickness. So we are using this intensity to measure the thickness. Okay, it's again the software gimmick, but there is a lot of I would say the softwares and algorithms are there. Let us not go into that. But what I'm trying to do is that depending on the coating thickness, so higher the thickness, larger the peak. That's the same thing actually, which I want to convey here. So the same applies during the coating thickness. The earlier software or earlier algorithm for bulk analysis or elemental analysis or ROHs is a typically elemental analysis. Here it is called the coating thickness. So we are just use the same XRF with a different software. So you all know the basics of XRF. I'll not go into again. So these are the some of the typical coating applications you might have seen. You might be doing it in your company, or you might be getting it from your vendor. Like for example, zinc on ferrous, nickel on copper, or if you're into connector industry, it could be gold over nickel over copper, and similar kind of applications in electrical contacts also. Let's say for example tin over nickel, uh, over copper or ferrous for example. So generally we people ask us a lot of questions. I mean, this is something which is very much important to understand. So now here I'm just trying to give explanation that the green one is a top layer, black is a intermediate layer, and orange one is a third layer, and then you have base for example, or you can take orange also as a base. So when a primary beam falls on the sample, it gives a secondary emission. Okay, from green, from black, and from orange also. Okay, so something similar happens when you are doing the coating thickness also. So and the left side image, it's showing kind of how the responses goes. Okay, so for example, if people ask me, can we do 50 micron, can we do 100 micron? So based on the element or based on the coating, what is this? If you see these curves, our curves are getting increased and then it's becoming plateau. So the what I want to convey here is that for every element, based on the coefficient of absorption of that particular element, how much X-rays it is getting absorbed and how much it is transmitting back or reflecting back. Based on that, it can be decided, for example, how much maximum thickness I can measure. In some cases, you can measure, let's say, 30 micron. In some cases, you may not even measure 2 micron. Okay, so this is typically the questions asked. So I thought just to, if whatever I'm saying it, if it makes sense for you. Something similar is happening. I'm just trying to explain with pointer. Okay, here, if you see here, the copper, I have mentioned the software, this software screen. So copper is the base. Then on top there is a nickel layer, and then palladium, and then there is a gold. So generally people say, okay, my gold is, let's say, flash gold, and then PD, and then Ni. So I cannot see the nickel layer properly. Okay, generally the people, these are the kind of complaints or application issues become. So generally what happens, if your top layer, whatever element you use for top layer, for example, if it has uh, if it is absorbing lot of x-rays, the reflection from the nickel, for example, will get absorbed in the gold layer itself, or maybe in palladium layer itself. Okay, it will not detect, it will not reach to the detector the x-rays which are reflecting from nickel. In this case, let's say, if your green top is very high, very thick, the reflection from the black intermediate layer will not reach to the detector, or even reach less. So you cannot measure this properly, or it will give the erroneous reading. So generally these are the question comes to us. So the common question in electrical electronics industry we get is, my tin surface, for example, on top layer is tin. I'm coating tin, let's say 8 micron. If you're coating tin, the like 6 micron, 7 micron, 8 micron, it is all the possibility. Below tin, you cannot see anything, because whatever reflection x-rays are going out of from the layer below tin, all everything is getting absorbed in tin itself. Okay, so it's always happen, if the tin is around 4 or 5 micron, okay, you can see the intermediate layer correctly. The moment you go tin 8 micron, there is all possibility you will get a wrong result of the intermediate layer. So these are the typical questions. I hope I am trying to make sense here. I think we have some application specialists also here. We can also ask questions after this my presentation. So we have different product lines basically for measuring the coating thickness, right from contact gauges to some of the high-end XRF machines. So all the modern XRF nowadays have a different, I would say, new features, something like our own modern X-ray platforms. So you have automated focusing, wide view camera. It can connect it to the SCADA, LIMS, and all those things. Now automated diagnostic tools are there, for example. So all the diagnostics information can be shared with the manufacturer, so they can suggest you something, where to when to change some parts and things like that. So generally, the modern XRF are like this now, with a lot of automated features. So this, what are the advantage of wide view camera? So for example, if you want to set up a, if you have XYZ stage, and if you want to measure let's say analysis on 5 different points, you can quickly set those 5 points with a wide view camera. Earlier used to be have only one single camera, like a big camera, but with a wide view you can select the points very quickly, and you can set up, you can do the analysis compared to very quickly than the standard or earlier XRFs. Okay, so something similar. So if you see, the standard camera view was very close. The wide view camera is from distance, so you can select the points, and instruments start measuring basically those points for thickness. Auto-focusing and auto approach. I think it is autofocus and auto approach is something very important in modern days, because automotive, because if you're focusing manually, some of the instruments earlier they used to have knob, and if you're focusing by manually, there is all possibility man to man there could be some variation. So now this with autofocus and with auto approach, you can remove this manual error. And definitely when once you keep a sample, automatically it get the sample get focused and get adjusted so that the focal distance remains same and you get a proper accurate reading all the time. So these are the all functions are available in all the modern day coating thickness XRF machines. So we something also have distance independent measurement. So for example, there is all possibility if we have putting couple of samples and one sample is having a different height, other sample is having different height, still automatically the instrument get adjusted and you can measure even if one sample is at depth, for example. So that is also something possible with new XRF. So this is also one of the feature I think what we have. I mean Hitachi has introduced first time, that is the standard less calibration. So typically in standard XRF instrument, we know that you need standards or infinites for the calibration for coating thickness. So generally, let's say if you're coating zinc in the range of 5 to 10 micron, we generally ask you you should have standards in the range of 5 micron, in between 7 or 8, and then 10 or 11 micron, something like that. So we used to tell customers you should have minimum 3 standards. Now with the new modern XRF instruments, we can actually do standard less calibration and still you get very accurate readings. Okay, so I given some example here. If you see here the precision in both the if you compare it, for example, gold and nickel, the precision values are very very good even without standards, using without standards. So we are not claiming here that customers should not use standard. If you want to go for audit, if your customers are asking for standards, you need to calibrate the instrument with standards. But if you do not have standards, still we can give a proper results. I mean the instrument is capable to give very good accurate results without standards. That's the I would say the FP engine. The algorithms are made such a strong way with the hours of, I mean, for the years of experience what Hitachi has in this field. Okay, there is one patented technique by Hitachi called the find my part. So that is also something very interesting. It's something based on an image analysis. So for example, I'll go to the next slide. So for example, if we have one part, typical part, and if you do it for the first time, and if you save this, automatically all the parameters along with this sample get stored. I mean what was the application you selected, let's say it is a zinc on ferrous, what was the collimator size, and what was the kind of other things, it gets stored automatically. When next time you put same sample in the instrument automatically detects that it's the same sample, and once it pops up, if you say yes it's the same type of sample, instrument will start doing analysis immediately. So you need not again select application or collimator or the other thing, for example. So this saves a lot of time. If you are doing same sample or something similar sample again and again, this is very very important feature. It saves a lot of time actually, and this is again developed by Hitachi for our new FT230 model or FT range of instruments. And of course, as I mentioned, now the information can be transmitted to the cloud. And Hitachi, if you are okay, if you activate, then Hitachi engineer can view the service data, the diagnostic data, the, for example, statistics for X-ray tube or detector temperature, error logs, and kind of thing. So even from remotely, somebody can manage. I mean, can basically view the data and suggest you basically what is happening with the instrument. So instrument or measurement results are not shared. Only the diagnostic data is getting shared here. So Hitachi or we are not interested in the customer's analytical results. But if you allow, then only we can able to see the diagnostic results, not the measurement results. And of course, we have all the accredited laboratories in USA and in Japan also, basically where we make foils, single layer foils, hard plated foils. Foils means basically standards. Some of the new applications update we have created, this we have done it in India. For example, we sold some new our equipment into green energy area for hydrogen fuel cells, where we have done like a platinum coating on titanium in the range of around 50 nanometer with our latest instrument. So that is a we have developed one application here, which is something unique. I would say it's a new field, green energy or green hydrogen. Again, we have done some multi-layer coatings for solar cell applications. So that is also we have done it successfully in India. So we just want to give some update on that. And it was very it's a very satisfying that we could able to serve these new areas and new applications. Then multi-layer coatings with FT 230 model, for example, even gold, we can go up to 0.036 nanometer, for example. If you look at the RSG values are very encouraging, very good at that level. Okay, we are getting very good RSG like 4% or something. So with our FT 230 model, I think we sold this to some electronics manufacturing company, high electronics manufacturing company. Zinc nickel bath, I think this is not new application, but if you see the RSG what we are getting with the new instrument, gram per liter, so we it's like for example 830 ppm of zinc for zinc and nickel bath, what we have done. So we are doing with our FT230 machines. So here is very encouraging. We have done the platinum bath solution where we have gone up to 25 ppm level with this machine. So that is also very good levels what we achieved with this instrument. Again, it is for precious element applications. So this is our complete range of products. So what we covered is basically if you want to do typically coating thickness application, we always suggest to go with a micro focus or micro spot XRF instrument. If you're going for ROHS or bulk analysis, elemental analysis, we recommend to go with a dedicated benchtop XRF for that. And if you're looking for like flexibility, more flexibility, then we always recommend to go with a handled XRF. Handled XRF is also capable of doing coating thickness. So there are just want to mention here there are multiple types of detector. Typically, what Hitachi used is a proportional counter and AZ detector. Most of the 90% of the application can be done on proportional counter detector, though it's old technology, but 90% of the applications can be done on that in a better way. SGD is something required for hand application, as I mentioned, precious element applications or nickel phosphorus kind of applications. This is something which I want to mention about the effect of measurement time. Generally, it is like a exposure, what we do with the camera also, for example. So if as you increase the measurement time, your precision level is definitely going to go up. Okay, generally people ask what is the measurement time, and generally we say 15 seconds, which is a it's a standard. But if you increase the measurement time, definitely you can increase the precision levels. Yeah, something similar here. So if you want to have, let's say for example, if you are plating gold, okay, we definitely would like to have more measurement time because you can save on that cost. Okay, if you otherwise unnecessarily put more gold, for example. So your reading has to be more precise in that case. Sorry. Again, there are we get lot of questions against, for example, if there is a change of substrate, the base metal. So base metal density, base metal has an effect on your coating thickness also. For example, brass. Okay, we say 60/40, but it is never a 60/40. It could be something different. It could be 61/39 something. Small difference can also affect coating thickness also. Okay, alloying element can also affect your coating thickness also. Okay, so there is a lot of interference can come from these alloying elements also. So we need to also understand these points, because I'm sure sometimes there is a kind of an arguments between the electroplating company and the component guys, that it is not happening properly, or it is not getting shiny, or things like that. But either the effect always happens, and even in measurement also these are also effects. So just take care of this part. When we talk to you, you can mention as a proper density which we can enter into the algorithm or in calculations which take care of your results also. So we can do the corrections. I mean, so yeah, so there are some typical sample positioning of the, I would say, makes a lot of difference. If your sample position is not correct, then also there is always variation in the result. I think so. Some of the customers we always recommend to make a jigs, okay, or some kind of fixture, so you can keep the sample, so you can keep it in all the time. All of your people, for example, if you're working a three shift, so they will keep the sample in a similar position, so there won't be any variation. For example, so we recommend this kind of tricks to some of the customers, and some customers already doing it. They only teach us sometimes. So something like this, they make fixtures. Yeah, so as I mentioned, handled XRF and benchtop XRF. Handled XRF is also capable of doing single layer thin coatings. Generally use better results when the layers are thin coating, for example, but single layer coatings. Okay, not multiple layer coatings. And if the parts are big, because in handled XRF the collimator size or the exposure area is very big. It's not in it's like 6 or something. So generally if the parts are big, we recommend to go for handled XRF. Again, we provide standards reference material which manufactured in Japan. We give certification, traceable certification for all the standards also, and you can buy from us or directly from some manufacturers globally which are available. So this is a Hitachi's history for last, I would say, since 70s. Hitachi is into the coating thickness business successfully, and we have lots and lots of installations in India and outside India also. So this is a total, I think, our offering for analytical instrumentation, XRF, ACM. I think for electronics industry, if you're from electronics industry, I think we have ACM, AS, then we have titrators, we have DSC TGA for polymer applications, phthalate analyzer, and UV spectrophorescence, for example. We have customer support team in India. We have a repair center for handled XRF, and of course, our distributor is also having their service center in Pune. Then we have our logistics warehouse. We maintain stock of spares as well as consumables in Mumbai, so we can support our customers in India. If I look at from XRF installations perspective, I think in India we might be having more than 5,000 XRF installed in India. So we maintain spares uh, and consumable basically to cater these customers in India also. And of course we have a lot of technical team in India. So that's all from my side. Thanks for your time. Okay.
So you would like to start with the Q&A session, or Love sir would like to share his point of view?
Yeah, maybe Love, you want to add something? Or You are in mute, love.
No, not at that time. It's fine. I think we already covered all the topics clearly. So it would be better we go for the Q&A session.
So your voice is not audible.
Yeah, man. Are you here? Can you hear me?
Yes, yes.
Yeah, actually, I'm just saying that already you covered all the topics almost.
Yeah.
So
I
can we go for the question and answer session? Yes.
Okay, so we will go for the question and answer session. Thank you for the presentation and very insightful. Thank you, CII, for giving us this opportunity. So let's start with the first question. So the question is there a provision to measure thickness on curved areas, or should the sample be perpendicular to the X-ray beam?
Yeah, actually, Neha, see your question is already means regarding the curve sample. So the first principle of the XRF that sample should be flat. But if there is any curve or any curve in the sample, so you need to have the smallest collimeter in this with your XRF. You can measure on the curve also. No need to put it on the perpendicular of the X-ray. Okay.
So I think Neha, the best what love is want to say is that if you have a small collimeter, then it will be also measure the curvature samples also very well. But at the same time, if it is a perpendicular, if the sample is curved and if the X-ray it is perpendicular to the beam, I think that will be also good for multi-layer coatings, for example. Okay, but generally, I mean, we would recommend a small collimeter, and at the same time, it's for perpendicular should be better.
Thank you. The second question is, can ROHS XRF analyze solid, liquid, and powder samples, and how accurate the results would be?
Yeah. Actually, we can measure with our instrument solid, liquid, as well as the powder also, or semi-solid also we can measure. So for this one, for liquid and for semi-solid, we have a cup, different type of cups. So we can use that cup and we can measure that semi-solid, liquid, and powder. Both. And accuracy for the solid or metallic part or semi-solid would be all would be the same. There are no big deviation rather than whether it is solid or liquid or powder.
Thank you. The next question is, how is accuracy compared to handled ROHS and coatings to tabletop XRF?
Sorry, pardon, yeah. RHS one.
How is the accuracy compared to handled XRF, ROHS and coatings to a tabletop, that is handled versus tabletop XRF, the accuracy?
Okay. So yeah, this is a little bit tricky question. Actually, what happened, the handheld, and if you want to compare the handheld XRF and benchtop XRF, there is a big difference of the two things. There is one is the exposure of the XRF that is based on the collimeter, and one is the wattage of the X-ray tube. So handheld XRF having the watt of the 4-watt tube, and while the benchtop XRF having the 50-watt tube. So that already explanatory that benchtop having the better accuracy rather than the handheld XRF. While at the same time, if you have the bigger samples, like say if you want to measure some big panels or something, then it is not quite possible with the benchtop. So for that purpose, handheld would be the helpful instrument for that.
Thank you. The next question is, do you have a demo facility to check the performance of XRF products in India?
Yes, I mean we have a demo facility. So at this point of time, we have our major facility in Mumbai for demo center, where we have all our equipment. But at the same time, we have a small facility in Bangalore also, where we have ROHS equipment at this point of time. So we can show the demonstration also in India for whoever wants to do that. Yeah.
Thank you. Do you have facility of creating definition files for XRF?
Definition file, actually, I just correlate with the application, right? Right,
Calibration
right,
files.
correct, correct. So we have the facility, and as Mahindra already explained, that our new instrument, that is FT230 model, is aligned with the standard less calibration. So if they want to add more calibration or more application, user can easily add that application even without the standard also. This is basically the our software is basically user friendly software. So just one training, you can add the standard as well as the calibration and application.
Thank you. With changing regulations, are there provisions to accommodate additional elements as regulated by the agencies?
Yes, I mean, see, when, for example, as I mentioned, for example, ROHS, at this point of time, they're only talking about five elements: cadmium, bromium, lead, mercury, and chrome. So, if they add something more, for example, tomorrow or something, some variant of other element, XRF is capable to measure, for example, benchtop XRF is capable to measure elements from sodium to uranium. So if they add something in between, definitely XRF can measure that. Okay. So I mean, this is about the XRF. So yeah, I mean, if it is fits in this range, definitely XRF can do that.
Okay. Next question is how to check coating thickness of individual layer in case of multi-layer coating. Is it only by removing the coatings or how is it possible?
No, not required to remove the coatings. We just need to calibrate the instrument for multi-layer coating thickness. Suppose that, for example, if you have the layer like gold on nickel on copper, like in PCB sector, so just we create the calibration that having the two layers application. So at the same time, within the same time of range, you can measure the both layers simultaneously to remove the layers.
Thank you. Can we check the thickness of cladded parts?
Sorry, pardon? Which part?
Can we check the thickness of cladded parts?
So Neha, I think the cladded parts are much thicker. I think, if I'm not wrong, uh, this is what I understand from cladding means. Generally, it is very thick. It could be 100 micron or maybe more than that. So it is not possible with a XRF. Generally, XRF plating thickness we can do roughly in the range of 50 micron or even less than that, for example. So cladding is generally thick. That's what I understand.
Okay, thank you. So another question on the location is it possible to have demo at customer's location and even can we do in-house calibration?
See, if it is a benchtop XRF, sometimes it becomes difficult to carry the instrument at a customer location because you need to transport the instrument. But if the instrument is there, for example, and for calibration we need standards. Okay, if it is our FT230 we may not need it, but then if it is a standard XRF machine we may need kind of standards. So if both the things are available, probably we can do the calibrations also. But generally we avoid transporting the instrument at a customer to customer site, because there is always possibility of damaging during transport, something like that. I mean, because it's typically bench top one, not a handheld one. If it is a handheld, we can carry, no issues at all.
Thank you. The next question, I think we will take maybe a couple of more questions in the interest of time, and we would probably get reply to the other participants offline. So the last question would be, what are the major elements to be tested and verified for ROHS compliance? And based on these results, can we meet the compliance for ROHS?
So when we see ROHs as a whole, you need to test six elements, six substance first with the EDX. That is a cadmium, chrome, mercury, lead, and bromine, PBD and PBDE. So these are the six substances they have to check for ROH's first part, and four phthalates. So if your compound or part is completely want to check the ROHS compliant, you have to test it for all these 10. But for example, your part is only metal part, for example, then there is no question of plastic in that. So there is no need of checking the phthalates in that part, because phthalates anyway won't be present at all in that particular part. So you have to only test for first six. Okay, but if your product is of plastic or polymer part, then you have to test for all 10 if you want to be compliant for ROHS. And if you want to measure all 10, you need for EDXRF for screening of first elements, as I mentioned, for cadmium, bromine, lead, mercury, and chrome, and TDMS for phthalates, because they are the organic substance. XRF cannot do all 10. XRF can only do elements. I hope I answered correctly.
Thank you. Actually, we do have some more questions and a little bit of time. So maybe if I can take up a couple of more questions. So one of the question is, if other than ROHS substance, we need to check other elements like carbon in steel. Is it possible to check with XRF, or is there any other solution you can suggest?
No, see, XRF cannot check carbon. Okay, any XRF instrument cannot check carbon, even if let's say somebody claims it is on like percentage, high percentage, which not nobody wants to check at that percent. So we generally say XRF is a blind for carbon, because generally XRF measurements start from atomic number 12, that is a magnesium, or 11, let's say 11 from sodium, if it is a benchtop and with vacuum. Carbon is atomic number is 6, so it is not possible with X-ray fluorescence technique. Generally, it is not possible, or let's say 99.999%. It's not possible. If you want to check carbon accurately, because generally the requirement to check carbon is always in the range of like zero point 0.3 or zero point 0.5, something like that. Uh, Low levels of carbons are looking in steel, for example. Then the best technique is optical emission spectrometer, which will give accurate reading, and it is as per the requirement for the industry, where you can actually give certification also for that particular result or analysis. So OES is the right technique for that.
Sorry, immediately a question has been asked if Hitachi provides any OES solutions.
Yes, we have. So we provide spark spectrometers also. We have benchtop spectrometer also, and we have portable spectrometer also, where you can do carbon measurement accurately.
Thank you. Coming back to ROHS, how are ROHS pass or fail criteria determined for an element?
Low.
See, the Neha, there is a regulatory defined this criteria, and the limits already defined by the different regulatory body. For example, that cadmium at the 100 ppm limit. So if anything going beyond the 100 ppm, it is showing as a fail. And these limits, like 2 point limit set the option in our software, in our ROHS software. If you want to set the something tight limit like here, if anything happened between 70 to 130 or 80 to 120, so it should be in gray area, or anything coming below that 80 ppm, it should be passed. So basically, these are the criteria, and all are set by the different regulatory body. And customer, user, or engineer can set that limit according to the requirement. It is possible with our latest software, with our RHF models.
Thank you. One more question is, can we check palladium layer thickness in gold plating with XRF or any other defect in palladium layer like crack or any other?
Yeah, I think,
Hi.
yeah, Raghu, carry on.
Sorry, continue. Sorry. I just joined. Continue.
Yeah, thank you. Actually, coating thickness we can measure easily gold, palladium, copper. No issue that in that. But unfortunately, cracks we cannot do with that XRF.
Thank you. In case of coating thickness XRF, is it possible to identify raw materials or raw material alloys?
Yeah, some extent we can have the calibration for the same, and we can identify the weights, we can identify the elements, we can identify the percentage available in the alloy. But if again, I just add one more thing on this question, that your earlier question regarding the carbon, if anything having the low alloy or like carbon silicon, that XRF can't detect on that. Rest elemental analysis is also possible, whether with the coating thickness instrument or with the RHS instruments.
Thank you. How can we test our sample if our sample is thin copper wire, like about 0.16 mm?
So for this is for coating thickness or ROHS?
For coating thickness, sorry.
Coating thickness.
Scanner.
What happens with our instrument? We have a different range of collimeter, from having rectangular collimeter as well as the circular collimeter. So if anything goes beyond the 0.1 mm, we can use our rectangular collimeter, that is 0.05 multiplied by 0.25 mm. So we can accurately measure even if it is 0.16 mm radius.
Okay. Can we measure tin thickness on copper wire?
Yes, of course.
Okay, thank you.
But
Can we?
thickness,
Yeah, please go.
Sorry, yeah. I just want to add, if they want to just adding some more things, Mahendra slide. If you want to measure the tin, they can go up to beyond around up to 40 or 50 micron easily in the single layer.
Thank you. Does Hitachi XRF machine has limits for acceptance, and what is the accuracy of XRF machine?
Can I answer this question, Neha?
Yes, please.
Yeah. Typically, accuracies are defined by layer wise. layer wise means it is like for the single layer there will be like from single to multi-layer there will be different accuracies defined. Predominantly for the first layer we will say around 5%, and the second and third layer it will be around 10 and 15%, because whenever you have a multi-layer coatings, you will have the absorption effects what Mahendra has already spoken about during his slides. He has explained on gold, palladium, and nickel on a copper in one slide, I think slide number 50 or something. So yes, we can do that one. There will be, see, it again depends on the calibrations also. How good is the calibration and what is the expectation or what is the range of the measurement, etc. It all depends on those also. Thank you.
Thank you. A calibration related question. So what is the calibration frequency on for handheld XRF?
See, generally, if you see from OEM perspective, we recommend to calibrate the instrument every year. Then, but it is customer has to decide when they want to calibrate, what is kind of load they are looking, or if they see any deviation in the results, for example. But generally, for handled XRF, we recommend to calibrate the instrument once in a year.
Thank you. Can we measure different layer thickness during gold plating?
Yes, it is there. Like, is it nickel or palladium nickel? Yes, it can be measured simultaneously. No issues.
Thank you. A question on support or service. Does Hitachi provide support AMC for yearly calibrations? And if you could just give a little more context to the support facility we have in India.
Yes, we do offer yeah, AMC services also for our all the XRFs, as well as we do like charge, like we can visit on call basis also. Both options are available for the customers.
Thank you. Can we measure solutions from plating baths?
Yes, yes. Depending on the what is the solution they are looking for. Like already Mahindra has shown the capability of zinc nickel solutions as well as platinum solution to the lowest level we have measured in the ppm levels. Surely we can do the solution measurement. Only thing is customer has to give us the known samples for the calibration, because as a manufacturer, XRF manufacturer, we might not be able to like get the samples for the calibration. That is, if customer has to give us the known samples, then we can surely calibrate the instrument.
Do you have any other analytical instruments to offer in electroplating?
Yes, we do have we do have equipments like auto titrators, which is one of the complementary technique for the every plating industry, where they can have like measure the solution uh, in gram per liter. Also, the impurities like NaCl or like sulfuric acid, those kind of things also can be measured in different solutions. We do have an application note for that one. We can share it offline to the required customers or required interested audience on that one.
Thank you. Another question is, can it measure tungsten coating thickness on brass or copper?
Tungsten thickness?
Tungsten thickness on brass or copper?
Tungsten thickness, how much? Maybe it depends on the thickness of the tungsten. For the tungsten, we can measure up to around 4 or 5 microns of tungsten we can measure. If it is more than that, it is very difficult to measure.
Okay, thank you. Another question on measurements. Can we measure hexavalent chrome?
No, unfortunately, hexavalent chrome or trivalent chrome is the bondings. Those are the chemical bondings. Chemical bondings, unfortunately, cannot be measured with XRF. Either you need to go for an UV spectrometer, which again Hitachi has as a different equipment altogether, Uh, and or otherwise you can go for uh, conventional spot test also, where it can differentiate between trivalent and hexavalent.
Thank you. And in the interest of time, I think I will take the last question now. And the last question is, can we get compliance for lube oils on XRF?
Yes, we do have application for that one. It is not with coatings XRF. Yes, we have a separate XRF called bulk XRF, which is a model called LabX 5000. In that, yes, lube oils can be measured, like the sulfur content or other impurities can be measured in that.
Thank you, Mahendra, Love, and Raghu. And now I would like to, yeah, thank you for all the questions. And now I would hand over to Ms. Reshma.
Yeah. Thank you to all our speakers and participants for joining this today's session. We hope you found the discussions, insights, and valuable. We appreciate your time and look forward to your participation in future CII programs. Thank you so much, sir. Have a great day, everyone. So,
Thank
you
you.
would like to give any concluding remark, please? Go ahead.
First of all, I would like to thank CII and all the participants, those who have participated and asked too many questions. I think we loved that. We really want to answer. If there are any questions, I think my email ID is there, or I can type it. I think please send us your questions, or you can try to connect us. We would like to answer your questions, or definitely. I mean, it's a very interesting. Once again, thanks to CII, Neha, Love, and Raghunandana to join this event also. Thanks.
Thank you so much, sir.
Thank you all.
Thank you all.